Hey folks, welcome back to the channel. Yeah, I know it's been a while since I uploaded any video on troubleshooting and I seriously apologize for that. It takes a lot of amount of effort and time for me to create these videos. I have to design these scenarios on my own. I have to write the code for them. I have to write video scripts. Then I have to actually shoot the video, edit and upload it, right? So that is like a too much effort. So if you haven't subscribed the channel yet, please consider doing so and yeah, leave a like for the video. Also, I would seriously like to thank all of you who have subscribed to the channel already. We are at 520 subscribers right now, and yeah, I'm really thankful for that. So, all right, without further ado, let's start with the video. So today we are making the fourth part of practical troubleshooting series. In this video, we will cover network troubleshooting. We have a very simple scenario. We just have a web server that is serving traffic on one of the endpoints. It is a very simple fast server. You can find the code for it in my GitHub repository. Again, we have a very simple client that is just a curl command that is making request to this to this server on this hello endpoint, right? I'm using curl watch command over here. So what this command do is it will run whatever command to you give it to watch every 2 seconds. So it is like watch will run this curl command every 2 seconds. So if I run this, if I hit enter, now you can see it is running this command every 2 seconds, and this is the response that I am getting. The very first thing is the HTTP code, HTTP version, what version of HTTP you are using. Then these are the HTTP status codes. So basically these status codes are to give you an idea like what was the outcome of your request. Was it successful? Was it failed? Or things like that. 200 means it is 200 OK is like the request was successfully served from the server. If there are things like 301, that means redirection. If there is 500, then there is some server error. If there is 400 something, then that is a client issue. For example, 404, it means not found, which means that you made a request to any resource that is not present on the server, right? So these are what the status codes are. Then again, it is a server version, and then this is the date. You can ignore this content type. They are not relevant right now. This is a response that you are getting from the server that says, hey, from the server, right? Now let's say something goes wrong with your server and your client started like client is not able to hit this particular endpoint. Now let's do that as well. All right, I need to open Ubuntu shell. Then I'll SSH into server. So we need server IP for that. All right, inputting the password. Enter. Then I'll run the script. That is a bad script. I have written a very intuitive name, right? Bad script. So it will cause something, and that will cause your client to actually not able to connect to your server anymore. As of now, the scenario is clear. We have a production server, we have a client. Client is not able to connect to the web server anymore, right? Now, where do you start from, right? So very first eliminatory test that we always do is we pick another client and we'll try making the request to the server from it. If that is successful, then we can conclude that something is wrong with this client, that previous client, right? If it is not successful, then we can conclude that something is wrong with the server, right? So in this scenario, if you try making the request to a production server, then you will notice that you're not able to make the request, right? But is it sufficient to make this assumption that the server is faulty, right? Like we can, but that is okay. Let me give you an example. For example, there is a website like, or there is a service, any big website like Google or Facebook, right? And something goes wrong, for example, and they stopped receiving traffic from India. In this case, if you pick any client from India, then you will not be able to connect to these websites. Whereas if you pick a client from, let's say, some other place, for example, US, then you will be able to connect. So based on the first test of choosing multiple clients from India, can you make this assumption that the server or the issues on the server side? Indeed it is, but not entirely, right? It is like, but still, to choosing two clients may be or may not be a sufficient criteria. So what else we can do? We can pick a client and we can start troubleshooting over there. And how will we do that? We will go layer by layer. We'll start with the very basic layer, and then we will move up the layers, and we will just try to find out on which layer there is issue, right? These layers are network layer, basically TCP IP model we will follow right now. So yeah, we'll start with the physical layer. So what to check with on the physical layer? It is the very first question, right? So first I'll SSH into client. client IP, and I'll check few things. First of all, the very first command that, okay, something is wrong. Should work. Password. Screen. All right. So very first thing that you can check is you can run a command that is each tool. So I'll run each tool. Still that is not working, right? Why? Because it expects you to give a network interface name to it. Now here comes another question: what are network interfaces, right? So there is something called NIC, NIC, or network interface card. Now what is that? That is a hardware that connects to your motherboard, and it will allow you to actually connect to any network medium. And when I say network medium, that could be a wire, for example, a Ethernet cable, or it could be a wireless medium like your Wi-Fi, right? So basically the hardware that is being used to interface with the network, right? In simple terms. How do you get that name, or how do you specify that interface? So Linux represents all of them using different names. If you do IPA, then you will get all of the network interface listed. The first one is the loopback interface. It is a virtual device. You can ignore this. The second one is what our Ethernet interface, like Ethernet network interfaces right now. You can see it is ENS4. In other devices, it could be ETH0 or things like that. Whenever you see something starting with E, probably it is a Ethernet interface, right? Ethernet network interface. So if I do sudo eth tool ENS4, I'll get something that is this response. Now what to check over here? The only thing that you are concerned about on physical layer is if you are connected to your network medium. If it is Wi-Fi, you are connected to Wi-Fi. If it is Ethernet, you have Ethernet cable plugged in, and that is being detected by your system as well. So you can see it says link detected, yes. So which means that we are connected to Ethernet. So that is all we need to check on physical layer. Once that is done, we can move to the second layer. That is the data link layer. Now what to check on that? There are few other things that you can check over here, but you can see some of this data is not even populated right now. Now why so? Because you can see it is unknown, right? Not reported, not no, and all of that. But why so? Because this is not this VM. This is a VM. It is not a physical machine. It is a VM running on a cloud. And what happens when you have something running on a cloud? The cloud provider will abstract lower two layers, lower two network layers. They started working from layer 3. Now this is not relevant right now. You can just think of it like there is an abstraction. You cannot see those layers or the data about them when you're running a VM on cloud. So I'll show you a standard ETH tool output. What does it looks like on a physical machine, right? So here are a few things that you should check. First one is the speed. So this speed is not the speed of your connection. For example, if you have a 500 Mbps connection, it will not be present here as 500 Mbps. So what the speed is, this speed is the maximum bandwidth that your NIC can support, that network interface card can support. For example, I have a NIC that can support 1 Gbps. So it will be represented as 1 Gbps, right? So which means that even if I plug a Ethernet that is connected to, let's say, a ISP router that supports 2 Gbps or 5 Gbps, then even in that case, the max speed that I can achieve using this NIC is 1 Gbps, because that is the maximum bandwidth it can support, right? After that, other thing that you should notice is this duplex, right? Now what do I mean by that is, so basically this should always be full. If you see this as half or any other thing, that is not correct. There are few other technicalities over there, like duplex means either you will transmit the data or you will receive the data. If it is half, like at one time you can either transmit or you can receive. When it is full, you can do both of them simultaneously. So just ignore the technicalities over here for right now. You can just think that it should always be full, right? Final thing is auto negotiation. It is okay if it is on, but I'll prefer if it is off. Now why so? What does auto negotiation means? That whenever you, let's say, plug in a Ethernet cable into a Ethernet interface or that NIC network interface card, they will negotiate on the speed, right? On the speed. If, let's say, for some reason this auto negotiation goes wrong and this speed is actually, let's say, instead of 100 it is 10 Mbps, then there is an issue. you're capped at 10 Mbps for no reason whatsoever. That is because this auto negotiation went wrong. So this should be false, and yeah, this should be the maximum bandwidth that your NIC can support. If you have checked these three things on the network on like in the each-tool output, then we can good to move with the other command, right? So that is done. What else we can check? Another useful protocol on layer 2 is ARP. ARP stands for Address Resolution Protocol. What this protocol will does, it will give you a output or a mapping from MAC address to IP address. Now, how that is relevant, I'll explain it later, right? What is the command that you can use to check that and verify that like ARP scan is already working? ARP scan is basically you will get all the IP to MAC address mapping in your local network. For example, if I run this command from my desktop, it will give me the IP address and MAC addresses of all the devices present on my network, on my local network. For example, if I run it from my laptop, I'll get MAC address of my mobile device, of my, let's say, PlayStation, things like that are there, right? So you'll run this command, that is localnet. As I said, we are running this command on a VM in one of the cloud providers. So the output will not be there because, as I said, they have abstracted the lower two layers. You cannot query any information related to them. So how does a localnet output, how does this ARPScan output looks like? I'll show you an example. This is how a standard ARPScan output looks like. You can see if you run this command, you will get these mappings from IP address to MAC address followed by this vendor name. Now, what this vendor name is, it is more like what is a vendor for your that NIC that is present on a device. For example, if I run it from my laptop, I'll get output like this MAC address followed by, for example, my other laptop that is from Gigabyte, so it will represent it as over here as Gigabyte. Or if that is a phone, that you can see things like the phone's vendor name, OnePlus, Apple, things like that, right? So if this command gives you the correct output, then you can conclude that, okay, we are done with the layer 2. There are no issues currently present right now based on our troubleshooting so far. All right, what we can do now, we can move to layer 3. Now, layer 3 is the layer that I think most of you are familiar with, that is the IP layer. Here comes the concept of packets that we use all the times, right? So how to confirm that and what to check here in the first place? So what you can do is you can run a command that is ping, right? And if you run this command, you want to actually, now what this command do first of all, right? So it is like it will send ICMP packets from your client to your server, right? And it will wait for a response. If it says ICMP hello and it gets back a response from the server, it can conclude that, okay, the server is reachable, right? Now let's do the ping test. What do we need? We need the IP of the server. So let's get that as well. I'll close this, I'll open another tab, and I'll do echo on server IP. So this is server IP. I'll copy this, I'll go back to client and I'll paste it. If I do this, you can see I am getting a response back. You can see this time, this is the total turnaround time. The total time from the starting with when you send a packet and you receive back a response, right? So it is the total turnaround time, and you can see we are getting the response continuously. When a ping test is failing, you will not notice these outputs. You will get things like timeouts and all. Then you can conclude that even the server is not reachable. So you can conclude that it is not reachable. It is not connected even to the network, right? So yeah, that is one thing. What else we can do? We can use a command that is traceroute. Sudo traceroute. So what does this command do is it will give you a path that your packets are taking while they are being propagated from your client to your server. Now, what do I mean by that? For example, I'll access google.com from my laptop in my home, right? Now, what will happen? A packet will be generated first. It will go to my home router. From my home router, it will go to my ISP's router. From my ISP's router, it will go to other ISP's router, tier 1 ISP router. For example, from my home, it will go to a local ISP provider. From that, it will go to Airtel. From Airtel, it will go to some other tier 1 ISPs, for example, AT&T. That is how the whole packet flow is. It will take hops. It will take hop from one device to another, and it will keep doing that until it reaches the destination, right? Now, let's say if some device in that path is broken, then your packets will never reach your destination. That is that is possible hypothetically. Like there are workarounds around this, like BGP is there to take care of it, but in a scenario it can happen, right? So if we do trace route, we can actually see the path that your packets are taking while they are like packets are taking from client to the server. And I'll show you a better example. I'll do trace route with xbox.com. So you can see these are the hops that my clients are that my packets are taking, right? But here comes a question: what are these stars? Right? What do we mean by these? To understand this, you first need to understand how does traceroute works. So traceroute works again. Traceroute uses ICMP, very similar to ping. ICMP is a protocol, by the way. It is a layer 3 protocol. Now what happens? Traceroute sends ICMP packets, and it specify the max number of hops a packet can take. For example, and what are hops, by the way, and what happens when you exceed that max number of hops. Now, as I said, when a packet started flowing from a client, it will reaches another, for example, a router, right? From my laptop, it will reach my home router. It will take one hop. If I actually set the max hop as 1, so it will take a hop from my client or to my local, from my local laptop to my home router. Then what happened? It has exhausted the max hop, that number, the max, and right now it cannot take any more hops. The router will consider, okay, this packet has expired, it cannot take any more hops. So router will respond back with a message to me that, hey sender, your packet has expired, it has reached its max hop limit. This is very useful thing, because otherwise the sender will never know that if the packet even reached the server or not, if it expired somewhere around, like some midway in, like through the whole journey, right? So that is what traceroute do. First of all, it will send a single packet with one hop, max hop 1. Then it will send a packet with max hop 2, so that it can actually log where the response is coming from. For example, when it set max hop as 1, it will get a response from my local home router. When it set max hop as 2, it will get a response from that ISP's router that, hey, it has expired at this step. If it is set as 3, it will get response from the other router, the one router that is ISP's router being connected to. That is how it will log all of these routers, right? By the way, these are not routers per se. We call them as autonomous systems or AS, but for the sake of like simplicity, just we can think of them as a collection of big machines or big routers, right? Yeah. We can make that assumption from now. Sometimes these routers are not designed to send back this notification of your packets are expired. So whenever that happens, you will see a star over here, because traceroute will get no response from that server or from that router that it has expired, that the packet has expired, right? So that is how the traceroute flow is, and these are what the star means. So once that is done, we can see at least we are reaching the server. So that is done. What else we need to check? So on layer 3, that is all you can check. Now we can move to layer 4, that is transport layer. And here comes even familiar protocols, TCP and UDP. You must have heard of them. So how do we what to check now, right? So one thing that you can check, you can try establishing a TCP connection with that server on the port that you're hitting. For example, for that I'll use a command that is telnet. I'll use telnet. I'll give it the server IP. This is server IP, and I'll give it the port. So the port is, we can get it from the client command. The port is 900. Yeah, 9000. Sorry. So I'll give 9000. I'll hit enter. And you can see it is unable to connect. It is trying to connect, but it can't. What else to do? We can try connecting on a different port. We can try connecting on port 80. And that works. Whenever you get a response like escape character is this, that means that the connection was successful. You're connected to the server, right? I'll close this. It will take a while because it will wait for that timeout to happen, TCP timeout, before disconnecting, right? So I'll wait for a while, let it happen. The connection is closed because that TCP timeout has happened. All right, what else to check? Now we know there is issue connecting to the server on this port, whereas we can connect to this port, that is port 80, right? Now we have to check why. What is the issue? Why we are not able to connect to this port? To do that, what you can do? You can do a packet capture. Now, what a packet capture is? So basically, like as we discussed so far, every data that you send to a network goes via the network interface card or the NIC, right? The same way, whenever you get a response, that will first reach the NIC, and then it will actually is provided to the process that are waiting to consume it. For example, your web server process, right? Now what we can do, we can capture all those packets that are coming and going from the NIC, and we can analyze them later. How to do that? We can use a command that is tcp dump. So what this command will do, it will do a packet capture on this network interface. It will store them in a file, and you can then analyze them, right? And we will do this both on client and on server. I have done it already on server. I'll again show you how to do that. So yes, you can run this command like this. You will let it run for a while. After a while, maybe 2 to 5 minutes, you can cancel it. You will get the files accordingly, and you can get the files and you can analyze them. You can use Wireshark for that. That is a very useful software. So if I open Wireshark, so these are the files I have got from both client and the server. Let's open the client file first. And one thing that we want to notice is we are interested in the outgoing traffic. We are interested in the traffic that is going from client to that server, right? And this is the server IP, that is 105. If you check these packets, like it is one packet, so one entry here is like one packet. If you see this, we sent a SYN. So what is SYN? Whenever we establish a TCP connection, there is a TCP handshake that is happening. It is like client will send a SYN, it will get a SYN-ACK from the server, it will send an ACK client, and then the connection is established. Then the data flow can happen. So this is the TCP handshake is. So you can see that our client is actually sending a SYN packet to the server, but it never got an ACK. It sent a SYN, it again sent a SYN, then it got some ACK, but these are not from the server, right? If these are from the server, then the source IP was that server IP. This server IP 105 should appear over here, but it is not, right? We can notice even here as well. We sent a SYN, we again sent a SYN, but we never got a response from the server. Let's check the capture from the server as well. So this is a capture that we got from the server. Looking at it, it seems like we are getting the SYN from the client, but we never responded back with an ACK, right? There is no ACK. You can see there is a SYN. This is a SYN packet. Then there's another SYN, another SYN, but there is there is not an ACK being sent, right? We cannot notice it over here. Like if that was the case, then this destination should appear over here. The same destination IP, client IP, should appear over here with an ACK packet here. It is not present. Now another interesting thing is, if you go to your server and you check these logs, you can see we are not getting any new request. The SYN packet is reaching the network interface of the server, but it is never being received by the web server process. It is slightly complicated to understand, but take a look at this example. It is like a packet comes, it reaches the network interface of that web server machine, but it never reaches the web server process that is waiting for that SYN to be acknowledged, right? It is not getting that SYN packet. That is why it is not updating an entry here. Now I have an idea that what is happening is those SYN packets are being dropped before they can even reach the web server process. There must be something or someone that is dropping those packets. Now, how to confirm that? So there is something called as firewall. Now, what is a firewall? A firewall is something that is both a hardware or a software. It can be either of those that you use to allow or disallow a certain traffic, right? So you can set rules like if traffic is coming for a single port or this port specifically, block this. If the traffic is coming from this client, block this. So you can specify things like that. Now IP tables is the default firewall that is being used by Linux. Now you can check if we have any firewall rule to actually drop these packets. If you do sudo ip tables minus l, now looking at this ip tables output, you can see there is a rule that says if that protocol is TCP, source is anywhere, destination anywhere, and if the port is 9000, then drop the traffic. And this is what that is happening right now exactly. The request is coming on port 9000 and it is being dropped. Now how to fix this? You can just flush these rules. If you do like this, then the rules will be gone. If you do a sudo minus l again, you can see we have dropped the rule, right? Now if you go back to your client, you can notice that we are able to again make a request to the web server, right? So this was a small demonstration of what is a common network issue that can happen, and some of the tools that you can actually use to do the troubleshooting. It is not a complete guide for network troubleshooting, but it should give you enough tools to actually start some kind of investigation, right? So if you like the video, guys, drop a like and subscribe to the channel, and I'll see you in the next one. Thank you so much. Bye bye.